Welcome back, viewers, and thank you very much for engaging on the last video. If you are a new subscriber, you're welcome, and if you're a returning viewer, you're also welcome. Right in front of us today, without further ado, is a particular topic in mathematics, and the topic is division. But then, there is a method to divide these fractions you're seeing here without the use of a calculator, and this method is known as long division method. And what is long division method? This is a method of dividing fractions without the use of a calculator. Yes, you heard me well. You can divide these fractions right in front of you without using calculator. Without wasting much time, let's get on. I already began the explanation here, but then I will take it all over again. First, you need to identify what is your numerator and what is your denominator. Numerator is the number above a fraction, while denominator is the number below a fraction. The next thing to do is to draw the sign you're seeing here, like an inverted L shape. Now, the numerator goes inside while the denominator stays outside. Having written that, then 5 in 16. What is the closest number that would give you 16 or something closer to 16? And when you do that in your multiplication table, you will have 3. So 5 in 16 is 3 times. Yes, we're going to have remainder. Hold on. So you write the 3 up here, because 5 times 3 is 15. It is not up to 16. That's why I said we're going to have remainder. But hold on. It will still surface. 5 in 16 is 3. Put the 3 above here. Then use that answer to multiply your denominator again. So 3 multiplied by 5 will give us 15. So we have 16, subtract 15, and we have 1. Or you can easily say 6 take away 5 is 1. 1 take away 1 is 0. So I often slash out the 0 so you know it's no longer included. Alright, that being said, we'll go straight over to the next thing to do. Now, we have 5 and then we have 1. 5 in 1 is not possible yet. So what do we do in cases like this? You would add 0 and introduce a decimal point. 5 in 1 is not possible. You need to add 0 and introduce a decimal point above. So the numbers we are writing up here serves as our answer. We'll get to that very quickly. Now, 5 in 10. 5 times what will give us 10? In your multiplication table, that will be 2. So 5 multiplied by 2 is 10. So 5 in 10 is 2. Put the 2 up here. Now, the next thing to do is to say 2 multiplied by 5, which will give you what? 10. Write your answer beneath. And what's the next step? Subtract again. Draw your line like a barricade. 0 subtract 0 is 0. 1 subtract 1 is 0. Or you can just say 10 subtract 10 is 0. When you have 0, 0, then you're done for cases like this. But there are cases whereby we'll still have some numbers, and we'll get to that in no time. Without further ado, here is our answer for 16 divided by 5. Our answer is 3.2. Let's go straight ahead to the second example, which is 209 divided by 7. Remember, the first thing to do is to draw the sign. Your numerator, number above a fraction, and your denominator, number below the fraction. Remember the first thing. Your numerator goes where? Goes inside. Your numerator goes inside the shape you've drawn, while your denominator stays outside. Now pay attention quickly to this kind of example. 7 in 209. Since you're not a calculator itself, you would have to use a different approach. 7 in 2. We still have all the numbers. You can't get 7 in 2, so you add the next number beside it. 7 in 20. Yes, we can get 7 in 20 to be 2, because 7 times 2 is 14 and 7 times 3 is 21. So the closest is 2. So 7 in 20 is 2. 2 multiplied by 7 is 14. What is the next step? Subtract. Pay attention. Draw the barricade. Now we are only subtracting 20 and 14. We are not touching the 9. We are only subtracting 20 and 14. We are not touching the 9. So 20 subtract 14 is 6. But then let's be more simplified. 0 cannot subtract 4. You can lend a 10. So adding a 10 to 0 is 10. So 10 subtracts 4 is 6. You'll be left with 1 10 here. So 1 subtract 1 is 0. You slash it out. So you can see we still have our 6. So 20 subtracts 14 is 6. Now what do you do with this 9? You use an arrow. You will use an arrow to bring down the 9. Now we are no longer having 6 but 69. Now 7 in 69. 7 times what is closest to 69? And the answer is 9. 7 times 9 is closest. 7 times 9 is closest because 7 times 9 will give us 63. So 7 in 9 in 69 is 9. 9 times 7 is 63. Subtract. Put the barricade. 9 subtract 3 is 6. 6 subtract 6 is 0. Slash. Are you seeing it now? Now there is nothing to bring down. We're just left with 6. Now, can 7 go in 6? Uh-oh. That's not possible. So what do you do in this case? Remember what we did here. We're going to do what? Add 0 and put a decimal point. So the same thing will be done here. We will add 0 and introduce a decimal point. Now we're no longer having 6 but 60. 7 in 60 is 8. 8 multiplied by 7 is 56. Subtract, put the barricade. Can 0 subtract 6? No. You have to lend a 10 and to be left with 5. Add the 10 here. 10 subtract 6 is 4. And you're left with 5 here. 5 subtract 5 is 0. Slash. You're left with 4. Can 7 go in 4? No. Add 0. But you don't have to put a decimal point again. So listen and pay attention. once you've included a decimal point in the first time, all you just need to do is to keep adding 0. You don't need to add decimal points again. So now we are having 40. 7 in 40 is going to give us 4. Because 7 times 4, it's going to give us 5, because 7 times 5 is 35. 7 times 4 would have given us 28. Am I right? Yes. So 7 times 5 is the closest. So you have to be very careful when you're doing this and make sure you're very, very conversant with your multiplication table. So moving on, 7 in 40 is 5, because 7 times 5 is 35, and that's the closest to 40. So put the 5 here and use that same 5 to multiply your 7 again. You have 35. Okay, that's why it's called long division. You can see the movements. Now 0 cannot subtract 5. You can just say 40 subtract 35, you have 5. But I like to be always simple in my explanation. So I can just borrow a 10. This will be left with 3. 10 subtract 5 is 5. 3 subtract 3 is 0. Slash again. Now, 7 in 5 is not possible. You add 0, but you will not add another decimal point. You just leave it that way. Now, 7 in 50 is going to give us 7, because 7 times 7 is 49. So you have 7 here. 7 times 7 is 49. Write the 49 here. You put the barricade, you subtract. We're going to be having 1. Okay? We can stop here, and I'll tell you why. The moment you have close to 3 decimal places, you're free to stop. You're free to stop, because the more we continue, we'll keep having numbers occurring and the decimal places will be increasing. So our final answer for 209 divided by 7 will be, here is our answer, 29.857. Very quickly, we have the last one, the last example here. And this example was coined out from the work we did from the previous video talking about the volume of a cylinder. Now we have 77 over 20. And how do we do that? Without wasting much time, draw the sign. The next thing is to put your numerator inside and put your denominator outside. The next thing to do is 20 in 77. I like to use the trial method. And what is the trial method? I will say 20 times 1, 20 times 2, 40 times 3, 60. Or I do the addition, multiplication using addition method. I can just choose to say 20, 20. What do I have? 40. And I'm still going to 70. I'll add 20 again. This is my 1. This is 2. I'll add 20 again. This is 3. I have what? 60. So now, I have gotten something closer to 77. If I choose to add another 20, I will be having, remember I'm plussing. I will be having 20 appearing the 4th time, and that will give me 80. But I don't want something that is above 77. I want something closest to 77, or if not 77 exactly. So this will not be included. We'll have 20 repeating itself 3 times, which was 60. So we can find 23 times in 77, which will give us 60. So 20 in 77, the closest we can get is 3. 3 times 20 is 60. You subtract, put the barricade. 7 subtract 0 is 7. 7 subtract 6 is 1. Now, here we go again. The moment you have 20 in 17 and you can't get an answer, remember what to do. Add 0 and what? put a decimal point. Now, you're adding 0 and you're putting decimal points. Very good. Now, 20 in 170. We can then continue back up here. So 24 times is 80. We can proceed to add another 20. And this will be the 5th time. And that will give us 100. We can add another 20, which will be the 6th time. That will give us 120. We can add another 20, which will be the 7th time. That will give us 140. We can add another 20, which will be the 8th time, and that will give us 160. Right? If we add another 20, which will be the 9th time, we will have 180, and we're looking for something that is closest to 170. We're going to stop in the 8th time. So 20 in 170 is 8, and 8 multiplied by 20 is 160. When you subtract, you have what? 10. How? 0 subtract 0 is 0. 7 subtract 1. 7 subtract 6, sorry about that, is 1. And 1 subtract 1 is 0. Remember, I left to slash the 0. So now you're having 10. But 20 in 10 is not possible. I need to add what? 0 again. But you don't have to put decimal point since you already have a decimal point here. So 20 in 100 is 5. And 5 times 20 is 100. In this case, we do not have any remaining number. So your final answer for 77 all over 20 is, the answer is up here, 3.85. So from the previous video, we did the volume of a cylinder. We had 77 over 20, and we ended up having 3.85 as the concluding answer. And this is a proof that you can actually use the long division method to divide fractions and get your answers correctly. So thank you very much. If you love videos and content like this, do well to hit the smash button, the like button. Sorry about that. We'll get familiar with all these things. Do well to hit the like button, and ensure you subscribe and drop a comment. This will help the algorithm to send these videos to those who need them. And don't forget to always pause and take the video back if you have any complication whatsoever at the course of the explanation. Bye for now. We'll have all the videos coming up later on this channel. Thank you and God bless you. Returning subscribers, I love you all. New subscribers, I love you. Thank you so much for the likes. They really mean a lot to me.